What if we told you that everything you see, touch, and experience originated from a single infinitesimally tiny point? Yes, that's right. Every star, every planet, every galaxy, and every speck of dust you see around you owes its existence to a singular, powerful, and yet unbelievably tiny occurrence known as the Big Bang. This isn't merely the stuff of science fiction, it's the very cornerstone of our understanding of the cosmos. The Big Bang Theory describes how our universe expanded from an incredibly dense and hot state approximately 13.8 billion years ago. Now, imagine the universe compressed into a space so small that it's hard to even conceptualize. Then, in less time than it takes to blink, this tiny point begins to expand. Not just slowly, but at a speed so unimaginable, it's beyond comprehension. In the immediate aftermath of this cosmic explosion, things started to get interesting. Fundamental particles, like quarks and leptons, burst into existence. These weren't just random particles, they were the building blocks of everything to come. As the universe continued to expand at breakneck speed, these particles began interacting, coalescing into protons and neutrons. But the universe wasn't done yet. As it continued to cool and stretch, these protons and neutrons began to combine, forming the first atomic nuclei. This was the birth of matter as we know it. However, for about 380,000 years, the universe was a hot, dense soup of plasma. Light could not travel freely, and the cosmos remained opaque. But as temperatures continued to drop, electrons began to bind with these nuclei, allowing photons to break free and light to travel unimpeded. This marked the end of the so-called dark ages of the universe and the beginning of the cosmic microwave background radiation, a relic of the Big Bang that we can still observe today. In the seething, opaque plasma of the early universe, the stage was set for the cosmic drama that would unfold over billions of years. This is where our story begins. This is the dawn of everything we see, touch, and experience. Welcome to the universe. Imagine a universe igniting with the first stars, colossal furnaces that synthesized the building blocks of planets and life. In the cosmic theater, gravity played the role of a silent puppeteer, pulling together nebulous gas clouds. These clouds, succumbing to the relentless tug of gravity, collapsed inwards, sparking the birth of the first stars. These stars, gargantuan compared to those we see today, became the crucibles of creation. In their fiery hearts, they performed a cosmic alchemy, fusing lighter elements into heavier ones. Hydrogen and helium, the universe's simplest elements, were transformed into carbon, oxygen, and all the other elements necessary for life. This process, known as nuclear fusion, was more than just a reaction. It was a mechanism for enriching the cosmos. As these stars reached the end of their lifespan, they didn't fade quietly. Instead, they erupted in spectacular supernovae, scattering their enriched contents far and wide. The stars in their fiery death throes scattered these elements across space, seeding the cosmos for future generations of stars and planets. In this cosmic nursery, our very own star, the Sun, was born. Our Sun's birth wasn't a solitary event, but part of a grand cosmic cycle. Picture a vast molecular cloud, an immense region of space filled with gas and dust. This cloud was not uniform but scattered with denser regions. Over time, these denser regions succumbed to gravity's relentless pull, collapsing inwards to form what astronomers call a protostar. The heart of this protostar grew hotter and denser, until finally, the pressure and temperature were high enough to spark nuclear fusion. In this fiery crucible, hydrogen atoms began fusing into helium, releasing a tremendous amount of energy. This process lit up the protostar, transforming it into a full-fledged star. And so, around 4.6 billion years ago, our Sun ignited. But the story doesn't end here. Around this young, bright star, a disk of leftover gas and dust swirled. This was the protoplanetary disk, the birthplace of planets. Over time, these particles began to stick together, forming larger and larger clumps. Eventually, These clumps grew into planetesimals, the building blocks of planets. In the inner regions of the disk, closer to the sun, the heat was intense enough to vaporize most materials, leaving only rock and metal to form terrestrial planets. Farther out, beyond what we now call the frost line, it was cold enough for more volatile compounds like water, ammonia, and methane to remain solid. These materials combined with rock and metal to form the gas giants. This process, called accretion, took millions of years, but eventually the gas and dust in the disk coalesced into the planets, moons, asteroids, and comets that make up our solar system today. And on a rocky planet we now call Earth, conditions were just right for the greatest miracle of all, life. From simple molecules to complex organisms, Earth became a cradle for life's diverse expressions. The exact origins of life remain shrouded in mystery, but it's believed that through a process of natural selection, simple molecules gradually evolved into complex organisms over billions of years. This process led to a mind-boggling array of species, each uniquely adapted to its environment. Then, in a relatively recent chapter of Earth's history, a species emerged that was unlike any other. Humans, with their capacity for self-awareness and intellectual pursuits, began to contemplate their place in the cosmos. Cultures rose and fell, philosophies were born, and our understanding of the universe expanded through science and exploration. As we developed technologies, we reached beyond our home planet, touching the moon with our footsteps and sending robotic emissaries to explore the far reaches of our solar system and beyond. As we stand at the threshold of cosmic exploration, the universe continues to reveal its mysteries, inviting us to marvel at the interconnectedness of all things. Yet, the universe holds profound mysteries that baffle even our most brilliant minds. Immersed in the vast cosmic ocean, we grapple with enigmas like dark matter and dark energy. These unseen forces, making up the majority of the cosmos, continue to elude our direct detection, challenging our understanding of the universe's fundamental forces. Our cosmic journey, too, is a testament to our relentless curiosity. We've leapt from our home planet to the moon, transforming a celestial dream into a terrestrial reality. We've sent robotic emissaries to explore our solar system and beyond, their explorations whispering tales of distant worlds back to us. We stand on the precipice of cosmic exploration, gazing into the abyss of the unknown, armed with nothing but our questions and our courage. As the story of the universe continues to unfold, we are reminded of our humble origins and the profound questions that propel us to explore the cosmos further.